Recording right now, okay?
Okay.
So this is a problem from so people can find it. This is from Mastering Physics. I don't know what number this is, do you?
6.
Okay. So Mastering Physics, projectile motion, and it looks like it's number 6 for you guys. All right, and you got a plane, right?
Yeah.
Why don't you read this top part?
Figure 1, a relief airplane is delivering a food package to a group of people stranded on a very small island. The island is too small for the plane to land on, and the only way to deliver the package is by dropping it. The airplane flies horizontally with a constant speed of 382
kilometers
per hour at an altitude of 875 meters. The positive X and Y directions are defined in the figure, where the parts assume that the island refers to the point at a distance d from the point at which.
So what's given?
How fast it's going and how high it's at.
So the airplane's trying to deliver a package so that it lands perfectly
On the island.
right there, right?
Yeah.
And as soon as something's released, it's going to change the direction it's moving, and it's going to change the speed. That's what projectiles do, right? Due to the acceleration due to gravity, the velocity that starts horizontal at the beginning, right? At the beginning, your velocity is horizontal, but then the velocity changes. So what we're doing is we're breaking the velocity up into horizontal and vertical components, right? And we're going to apply our equations in the x and y direction. So what's given in this case? We got v naught x, v naught y, we got ax, we got ay, right? What else is given? We got. I'm going to speak in terms of delta x and delta y displacements. Are you good with that?
Yeah.
Do you know what displacement is?
Yeah.
What?
Delta.
Yeah, but that means it's a change, right?
Yeah.
So it's a final position minus a beginning position. Like the equation on your equation sheet, it's written in terms of position. And you would have to subtract initial position from both sides of that first equation in order to use it the way I'm using it. I'll show you how to do that. So, do you know what initial velocity in the x direction is?
0.
Keep trying.
382.
There you go. And I'm going to convert it to meters, I think, right off the bat.
I thought it was supposed to be a mile.
No, it looks like kilometers. So 382 kilometers per hour is going to be, if I convert the kilometers, I'm just adding 3 zeros, right? So it's 382,000 meters per second.
Yeah.
All right? And that's also my x velocity. Because does your horizontal velocity change when you're in the air?
No.
That you did that in the lab. What's your initial y velocity for the package? When it's dropped, which way is it moving?
This way. This way.
It's dropped. When it's dropped, it's moving with the plane horizontally only.
Oh yeah.
So it hasn't started moving in the y direction yet at the instant it's dropped. It will quickly. It'll speed up in the y direction. But at the moment it's dropped, there's no y velocity yet. And then the x acceleration, is there any?
No, what is constant?
Good, because there's no net force in that direction. What about the y acceleration? Okay, good. Now, they've made y up, in their diagram, they show y up being positive. So that means acceleration's negative.
And what is O? It might be
And what's your change in position horizontally? Do you know that?
Yeah, so look up
Or no? They don't give you how far they want the package to travel. They don't give you D.
Oh, no.
Huh? Okay. So you're finding D. Maybe down here I'll write D equals question mark. And I'll call this delta x. Does that make sense?
Yeah.
Alright. Erase that one. Cool. So, I don't know, what's your strategy to find time? Do you want to use an equation or do you want to use a graph? What do you
Equation.
Which equation?
Delta y.
Okay. Delta y equals what?
Initial velocity.
Do it your way.
Oh, we know the delta y. What's the delta y? I
What do
forgot.
we do? Oh, it's 875.
Okay. So that's the height of the plane. Now, it's not 875.
Okay.
Which direction's positive?
Negative.
Up or down?
Up.
So this is a negative 875. So be careful. With every quantity, make sure you check whether it's positive or negative. Okay? So you said you want to use the second equation on your reference sheet? And your second equation is y equals y naught plus v naught yt plus 1/2 ayt squared. Right? And these are vectors, so I'll just put vectors on. Cool? If I subtract y naught from both sides, I get delta y equals v naught yt, and I think that's what you were telling me a minute ago, right?
Yeah. But since there's no initial velocity,
Excellent, very good. So, what now?
plug in 9.8 for acceleration, and then
Do you have your delta y?
Yes. Negative.
What are you looking for here? What are you going to be able to find? Alright, so time is going to be square root of 2 delta y over ay.
Yeah.
Does that look right?
13.4.
Okay. So that's going to be, whoops, I didn't mean to do that again. So this is going to give you 13.4 what?
Seconds.
Okay. And you already did that.
Yeah.
Alright, so you found the time for what?
For how long it takes the package to drop to the island.
So that's the time for package to hit the ground. Alright, cool. Now that you know that time, what are you trying to find? Part B. Okay. Now, in the x direction, in the horizontal direction, what's the acceleration?
0.
Okay. So if you want to use an equation or a graph to do this?
Equation.
All right, which equation?
Delta x.
Let's see, that's all I want.
All right, I'll write the same equation.
No way.
I'm guessing you want to use this one again.
Oh, it's this one. Oh, no, it's this one. Oh, no, it's this one.
Yeah, that's why.
Right? I'm putting x everywhere to remind myself that I'm using this equation horizontally now. Right?
Yeah.
As opposed to over here, where I used it
Oh, then I
vertically.
got a 50% on mine.
Yeah?
Yeah.
All right, so what's acceleration horizontally?
0.
Okay. So you get delta x equals vxt. I'm going to ditch the v naught simply because the velocity never changes horizontally. All right. So you're looking for delta x?
Yeah.
Do you know vx?
Yes.
Does v ever change horizontally?
No.
Saturday?
So you just need to they want the number in meters? Yeah, they do. So 382,000 meters per second. That's my velocity in the x direction times what?
Time?
13.4 seconds.
Yeah.
No.
And what do you get?
I have no clue.
Yeah.
Try it. See what you get.
Okay.
Wait. Tell me what I have to
I got this.
What's this?
5,118,800
And do they want the number expressed in a certain way?
meters.
You gotta do more.
Okay, they probably want how many sig figs?
3.
All right, so that would be 5.1 1, 2 times 10 to the what?
I just did like the
2.
1, 2, 3, 4, 5, 6 times 10 is 6 meters. There you go.
Like, this is what I have.
Are you sending me a snap just to
I have 2, 7, 13, 9,
1, 2.
You're going to have to use those special buttons.
and 25.
Which one?
Alright, so the problem with this is kind of annoying, but okay. So the problem, we made a mistake here, is that right there. So let's see here. How can I erase? Oh man, I can't. Oh, I don't want to do that. Whoops. So let's try this again. All right. Let's see here. All right, that looks good. So that is a problem because that was meters per hour. So we're gonna have to convert hours to find, because this is wrong. What we got to do is change. See, I'm gonna erase this to make room. So we have to multiply by, let's see here, 1 hour, 60 minute, right? 1 minute, 60, hard to see that, seconds, right? And if you notice now, my units work out, seconds, minutes, hours, and then I'll get an answer in meters. So it's actually going to be,
It might just be that.
let's see here, 382.123 times 13.4 times 1 divided by 60 divided by 60. I'm getting 1,000, so it's 1.42 times 10 to the third meters. I didn't convert units correctly. I needed meters per second here first, multiply by seconds to give me my answer in meters. Anyway, there it is. Have a good day.